Okay, so if we have a brick and a phone, again, I don't draw, so if I want to find out the distance from this brick to this phone, it's sufficient enough to find out the distance from the brick to any button on the phone or the screen. So if this was an iPhone, I could easily just find out the distance from this brick to the home button, and that will give me the distance from the brick to the whole phone. So this applies with planes too as well. So if I have a plane Q, no, let's stick with convention. I've been doing pi all that time. So if I have a plane pi and I want to find out the distance from some point Q to pi, it's sufficient enough to find out the distance from the point Q to any point on pi. But I want to find out the shortest distance from Q to pi. So I could choose this point there, or I could choose some point over there. But I want the shortest distance from Q to pi. Now, if you remember, vectors can be split into their x and y components. So let me just go back a minute. So let's say I choose a point Q, a point A on pi, and this distance here is the same as going down and to the left. Yeah. This distance here to B is the same as going down again, even more to the left. So we've traveled a lot more further from Q to A than Q to B. So Q to B is basically a longer distance. The shortest distance is the point where Q just goes straight down to this point here. Instead of going left or going right, Q just goes straight down. So the shortest distance will be this distance, this point here, which we'll denote by C. So if I just redraw this, we have the point Q, then we have our point C. So this is the shortest distance, and I'm now drawing my normal vector. So what you can see about this, the relationship between this vector here and the normal vector is that the normal vector is parallel to QC. Now, again, we can't do anything because this is a position vector, this is a bound vector. So we need to change this in terms of position vectors. Again, remember that the thing that we're trying to do now is find the distance from Q to C. So that's our main goal, what we're trying to do. And we've just found out that the normal vector is parallel to this vector that we want to find the distance for. So if I say that C has position vector, the point C has position vector C, Q has position vector Q, then I can either use Q minus C or C minus Q. I'm going to say Q minus c, because the distance from c to q is the same as the distance from q to c. So q minus c is parallel, which means that there is some alpha or lambda that I can multiply by the normal vector to get this. Okay, so we have this relationship. Now, what do we actually want? Remember, we're trying to get the distance, this distance. So what we really want is the distance of q minus c. So this will be the, whatever this number is, multiplied by the normal vector. But we have no idea what this number is. So we need some special way, or we need to do some calculations to figure out what this lambda is. We already know what n is, since we need n to define the plane, but we have no idea what lambda is. Okay, so what we're going to do is we're going to take the dot product of both sides. Maybe I should... Okay, I'm going to show you something real quick before I switch the page. N dot n, if we look at n dot n, it's n1 squared plus n2 squared plus n3 squared. Now if we look at the length of n, this is equal to the square root of n1 squared plus n2, this is wonky, the length of n is the square root of n1 squared plus n2 squared plus n3 squared. So if I square, then I have n dot n. Yeah, so if I square both sides, then I have this. If you don't know how this equals that, or that equals that, then you're going to have to check a previous video or just Google it. So, okay, so this is what we need. Q minus C is equal to lambda n. I'm going to go to a different page for this. So what we're going to do is we're going to dot n. We're going to take the dot product of n for both sides. So we have Q minus C dot n is equal to lambda n dot n. So Q dot n minus C dot n is equal to lambda mod n squared. Now you'll see why we did this. So we have Q dot n is that clear enough? Q dot n minus C dot n divided by lambda divided by the length of n squared is equal to lambda. So now we have lambda in terms of things that we should know. So what is Q dot n and what is C dot n? If I go back to so C is a point on the plane, and Q is the point that we want to get the distance from Q to C, but C is definitely a point on the plane. So C dot n is equal to D. Whoa. This is because this is from the definition of a plane. If we take the dot product of n with some point on the plane, then we get D. Yeah. So C is a point on the plane. If we take the dot product with n, the normal vector of the plane, we get D. So what we have here is Q dot n minus d over mod n squared, which is equal to lambda. When we get given the plane, we will have d, because whenever we define a plane, we always have d, which is on the right-hand side. Q is the point that we're trying to get. We're trying to get the distance from Q to the point on the plane, so we will be given Q. From the definition of a plane, we'll have n, and we can figure out mod n squared. So lambda, we can calculate lambda now. So if we go back to this, then we'll take this. If I copy, so oops, Q minus C is equal to lambda n. If I paste this over here. Okay, so now we can say that Q minus C is equal to Q dot n minus d divided by lambda n squared multiplied by n. Now, if you remember from here, lambda n squared is equal to n dot n. So if I then do n divided by mod n squared, I get n on the bottom. Yeah, because mod n squared is equal to n dot n, which means that if I do mod n is equal to n, yeah, then if I then take the reciprocal, n divided by mod n squared is equal to, so n divided by mod n, the length of the vector n squared is 1 over n. Divided by n. So this n came from there, and this lambda we figured out, so Q minus C is equal to this. But this isn't actually what we came here for. We came here for the length of Q minus C. So what we can say is that Q minus, if we just put the modular signs in, we can just do mod. Yeah. So the length of Q minus C is the length of whatever's on the right hand side. This is the distance from a point Q to some plane, sorry, yeah. Yeah, so it is the distance from a point Q to a plane.